Hello everyone, my name is Amir. I'm a PhD student at TUDelft and also a software developer in the FOSDEM project. I'm very pleased to present our project Fasten at FOSDEM 22. Nowadays, we use open source libraries as a building block to create a new piece of software because we would like to save development efforts and costs. When using open source software, we deal with direct dependencies or general dependencies as shown in this illustrative example. Let's say in this case your application is a Java project and you use the log4j package as a direct dependency, and of course the log4j package has its own dependencies, which is called transitive dependencies in this case. There are thousands or even millions of software packages in a software ecosystem, such as Piper or Maven. These create a huge network, which is called package dependency networks, or PDNs in short. Such a network oftentimes have complications like version constraints, which even make these networks even more complicated. Or even if a security vulnerabilities exists in, let's say, one of several packages in these networks, then of course other nodes or packages will be affected by a vulnerability. Or if there are license violations in other some packages, then the packages that depend on that particular package will be affected as well. Given the complexity of PDNs, in recent years we have witnessed several fatal failures. For example, in 2016 we had the left pad incident. Basically, one JavaScript developer removed his package and caused a big trouble for the JavaScript community. And similarly, we had the Equifax data breach in 2017, which revealed many credit card information of Americans. And very recently we have witnessed the log4j vulnerability, which potentially could affect millions of consumers in the world. The said issues or the said failures about the PDNs are caused by these problems here. For example, the update problem. Is it safe to update a package in such a big network? Or for example, the compliance problem. How to know if a package is safe to use in terms of license and copyright violations. Or the deprecation problem. Some packages in the PDNs are outdated and no longer maintained. And also software developers might lack incentive to work on software projects or on those outdated projects because they work for free. And they might abandon open source projects at any time, which causes problems for others who use that package. There are existing solutions to the issues of PDNs that I described before. We have services like Dependabot by GitHub, or we have other services by other companies. These services, to the best of our knowledge, have several problems as stated. For example, there are no support or limited support for assessing updates, meaning that is it safe to update a package, or is it safe, for example, to update to a particular version? And they provide no help with impact assessment. Let's say if I am a library maintainer and if I change a function in my library, how many clients will be affected by that change? And last but not least, they suffer from false positives. The current solutions mostly focus on the packages themselves. Basically, they analyze software at the package level, and they usually don't consider the source code or even deeper analysis such as call graphs. On the other hand, we have call dependency networks, which analyzes not only the application itself but also its dependencies, as shown in this slide. Basically, it creates a call graph of the application plus its dependencies. It starts from the entry point of the application, which is main in this case, and creates a call graph for deeper analysis, which potentially may help to reduce false positives in the analysis. Inspired by the issues of PDNs, as I described before, we started the Fasten project in 2019. Fasten stands for Fine-Grained Analysis of Software Ecosystems as a Network. It aims at solving the described issues of PDNs by making package management more robust. We also have a centralized service to host the graphs and to serve expensive analysis such as producing big call graphs. The Fasten solution, in short, has a number of features. First, we provide more precise analysis in some aspects, like license compliance. We consider the files in projects, and we basically analyze each file and its license information to make sure that the application and its dependencies are compatible in terms of license compliance. We provide more precise security analysis. For example, if a dependency has a vulnerability, does it affect my package? We provide such information. And we also provide impact analysis. For example, if I change my package, or if I change, let's say, a function in my package, how many clients or how many users will be affected by that change? And we also aim to provide integration with package managers, and we are currently working on this feature to provide Fasten solutions with the package managers like PyPy and Maven in the very near future. This is the overview of the Fasten architecture or project. On the left side, we have data streams from multiple sources, from GitHub, for example, or package repositories, Maven, Debian, PyPy. As of now, we currently support 3 ecosystems: Maven, PyPy, and Debian. And we also get vulnerability information from the NVIDIA databases and more sources for vulnerability information. At the middle, we have the Fasten analyzers. The most important one is probably the call graph generator, or the core analysis. We have the analysis layer, which uses the call graphs for security analysis, compliance, quality and risk, and change impact analysis. And we have the storage layer to store the call graphs and to store the the results of the expenses analysis layer in the Postgres database or in a graph database like RocksDB. On the other hand, we share our analysis and data in our storage layer via REST API and also a web UI. The package managers or the extensions for the package managers will reuse our REST API to provide security vulnerability information for users or license compliance features, and also impact analysis for developers. Here is one example of Fasten workflow. Before Fasten, people use pip, a package manager for Python, which analyzes all the dependencies and or even updates the dependencies and installs them. On the right hand, we have the Fasten extension for pip, which provides more information for Python developers, such as security vulnerabilities, license compliance, and change impact analysis. That's our goals, basically. At the moment, we are working on this feature for package managers, but this is an illustrative example to showcase what Fasten will look like in a package manager. One more example is to use Fasten in pip or even in Maven to decide whether to use a particular package or not. In this case, we have Tornado, for example, and we would like to see, or developers would like to see, how many maintainers the package has, the community size, and more importantly, what is the latest vulnerability in the package and all of its known vulnerabilities, and also license rating, whether it's compatible or not with the application. This is our Fasten Concertium, which consists of multiple companies and universities in Europe, and we all together were working on this project to provide developers and the software communities and software ecosystems with vulnerability information, change impact analysis, license compliance, and more. And finally, thank you so much for listening to this talk, and I appreciate your attention. If you have any questions, comments, and things to discuss, please feel free to ask your question or leave a comment. Also, you can visit our website, fasten-project.eu, for more information about the project. If you're interested in the development part, or if you want to contribute to our project, please feel free to visit our organization on GitHub. And you can also follow us on Twitter for the latest news and releases. And again, thank you so much for your attention and time.